Okay, if you're given a problem and you're trying to find the z-value at 0.83, remember that this is area, and so what you're given is that this area in here, all of this area, is 0.83. Well, probably one of the most important things to remember is this entire curve adds up to 1, because all probabilities add to 1. So in other words, if I shaded this entire area, you'd get 1, and that is very, very, very important. Why is that important? Well, because then if I have, get me another ink color here, I want to be able to find, my ultimate goal is to find the area from here to that line, and that's the z-value. That's just how the z-table is made out, is you read from the very bottom, from minus infinity all the way to the end, to the z-value. So the problem is then, is I have some area that, if you notice, is not shaded in, which is this area right here. So I've got to figure out what that area is. Well, if the entire curve adds up to 1, then I would know these two areas would be 1 minus 0.83, which would be 0.17. But then I have to take it and cut it in half, because half of it's here and half of it's here. So if I take 0.17 divided by 2, I get 0.085, and that's going to be the same area over here. If you don't believe me, add 0.085 plus 0.83 plus 0.085, and you will see you'll get 1. Okay? So now, as I can see, I want this red area, trying to get my red pencil back, I want this entire area, which is the middle 0.83 plus this area 0.085. So I add those together, so 0.83 plus 0.085, and I get 0.915. And typically you're going to see in the table areas we like to put in 4 digits. So I go to my table, so I simply either find a table online or the table in a textbook, and I look for the area that is closest to 9150, and I actually find this area 9147, that is the closest. And I read the z-value by looking at the row 1.3, and then it's under 0.07. So 1.3 plus 0.07 would be 0.137. So in other words, this z-value right here equals 1.37.